Quadrantial angles. What the heck does that mean? I'll discuss briefly at times. Let's go into a little bit of depth. So let's go to our XY graph. And we've already seen, we can go around. That's 0 degrees. That's where we start, right? In our standard position. And then we go up to 90 degrees. We got 180 degrees. We got 270 degrees. We go around in a circle. We go to 360. Shit, if we wanted to, we just keep going and call this one 450. Because it doesn't matter how many times you spin around in the circle. It only really matters where you end up in trig a lot of the time. But whatever. I'll cut these things out. Now these are quadrantial angles. They're all quadrantial angles. Because you look at, say, 90 degrees. And I ask you, is it in quad 1 or is it in quad 2? And it's not in either of them. And it's not in either of them because it's the borders. Quadrantial angles are the borders. So with everything that I got there highlighted in pink, that's your quadrantial angles. Cool. But degrees are dope and all. They're fun for like understanding. We got to start getting better with this and saying that this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and we come back around to 2 pi. Now, if I was to keep going around in the circle over and over and over, 5 pi over 2, 3 pi, this would be 7 pi over 2, go back around, now we're at 4 pi. Just keep playing this game, like 9 pi over 2, and then this one can be 5 pi now, and then we can go around to this, and this can be 11 pi over 2. And we can keep going and going and going and going and going with our coterminal angles, right? So, but if you notice, look at this axis. Let's just take a look at this, the y-axis. Look at all of your radians. It seems like if you're ever on the y-axis, you're always at an odd multiple of pi over 2. That's the first time I say that phrase. I will say it at least 30 more times. Odd multiples of pi over 2. Cool? Cool. All right. Let's go look at a particular one. A particular. Now, if we remember from last time, we had the sine of an angle we could say is y over r. Cosine of theta is equal to x over r. Tangent of theta is equal to y over x. So let's play some freaking games. Now, this is essentially what we're showing here is, I'm going to draw like the unit egg, but whatever, it's supposed to be like the unit circle. It's like the unit circle. Look at what's the radius of this circle. How far is it from the center over to, what's the x value? 1. How far is that? It's 1. It's 1. So if we're at a quadrantial angle, you know what you're not going to get? A triangle. Let's try and draw a triangle here. Let me put something here, pi over 2 or 90 degrees. Now let's drop it perpendicular. It's not a frickin' triangle. So if you're leaning on the idea of, oh, I just make a triangle every time, the quadrantial angles are kind of your kryptonite. So we got to get these just dialed in. So let's just look at our first one. At 0 radians. At 0 radians or 0 degrees, we're going to say that our sine of 0 radians, you can tell it's a radian because it's not a degree symbol, is going to be our y value over our radius. And our radius is 1. Right, there's your y value. So we're going to say it's going to be 0 over that 1, the radius, which is equal to 0. So sine of 0 is equal to 0. Cosine of 0, well, that one's equal to our x over our radius. So 1 over 1 over that 1 is equal to 1. And now let's go get tangent of 0. And what's nice about tangent is just 0 divided by 1. Your y divided by your x, or sine divided by cosine. Sine divided by cosine, so what's 0 divided by 1? And that is 0. So just to make the table, I'm going to get that out of there a little bit. And you can see that sine of 0 is equal to 0. Cosine of 0 is equal to 1. Tangent of 0 is equal to 0. Now let's move on to our 90 degree. Let's pop it up right up here. Boom. Oh, I mean pi over 2. And I'm just writing in radians at the moment. I'm not going to mess around with any degrees. I'll speak it, but The angle goes inside the trig function, so sine of pi over 2 is our y value over the radius, and the radius is 1. So what's 1 divided by 1? It's 1. Cosine of pi over 2. Well, cosine is going to be our x value over the radius 1, so 0 divided by 1 is equal to 0. Now we go to tangent of pi over 2, and we look and we go, uh-oh, 1 divided by 0? You can't divide by 0. That's nonsense. That must mean that we're undefined. So there's our 90-degree angles, or oops, I'm sorry, pi over 2 radians angles. There's our 0 degrees, or 0 radians. Let's keep playing the game. Only a couple more. Let's go get, let's bring ourselves over to 180 degrees, or pi radians. And hopefully you can see how this game is going to work already. So sine of pi is equal to our y value over our radius. So 0 divided by 1 is equal to 0. It's like sine of pi and sine of 0 are the same thing. Oops, I'll write that color. Now we go to cosine of pi. Now cosine of pi is going to be our x value, -1 over our +1. So -1 over +1, that's -1. Hey, look, it's the same number, just a different sign when it crosses over the y-axis. And lastly, we're going to go get our tangent of pi, and tangent of pi is equal to 0 divided by 1, so we get -0, right? Or, I'm kidding, just 0. There's our 180-degree angles. Lastly, let's go get it. We're going to go find sine of 3 pi over 2. We're going to find cosine of 3 pi over 2. And then when we're done, we'll get tangent of 3 pi over 2. Let's move our radius on down. Big old dot. And we're like, okay, the radius is 1. Our x is 0. Our y is -1. So sine is equal to our y value, -1 over 1. -1 over 1 is equal to -1. It's like the y values are negative down here or something. You know what I mean? And it's like the x values are negative over there. You know, like cosine. It's like that's happening. So having that little bit of knowledge, that trick kind of helps out. So cosine of 3 pi over 2 is going to be 0 over 1 for 0. And once again, we go to get tangent, and -1 divided by 0, that's undefined. So it looks like every single time you're on the y-axis here, tangent of anything there is going to be undefined. So I'm just going to write it in a little bit weird. I write a pi over 2 and I'm going to write an a in front of it. So anytime you have an odd multiple of pi over 2, some sort of odd multiple of pi over 2, tangent will be undefined. I wonder if I said that. Yeah, okay. Odd multiples of pi over 2, tangent is going to be undefined. I wonder if you can figure out where cotangent would be undefined. That'd be a great little test question asking about where cotangent would be undefined. But, you know, let's move. Cool. Well, we got them all. This is sweet. Well, let's just move into one little piece, and then we'll move on to the next. I'm just going to go above this. So let's just look. We got sine. So sine of 0. I wonder what cosecant of 0 is. Now, I'm not going to do all of them. I'm just not. And then we're going to have what goes with cosine. That's secant, right? And then what's going to be cotangent, right? There we go. And that's all of 0. Now, what's the reciprocal of 0? And don't you dare tell me it's 0. No, the only two things that are equal to their reciprocal, only two numbers that are equal to their reciprocal are +1 and -1. That's it. So let me write 0. 0 over, it doesn't freaking matter. It was 0 over 1. When we flip that thing over, you get 1 over 0, which is undefined. Well, since cosine of 0 is equal to 1, the reciprocal of 1, oh shit, it equals itself, so it's just still 1. Cotangent of 0 is the same thing as tangent of 0 flipped over, but I've already shown this trick. It's just like sine was equal to 0, we flip it over, and it is undefined. That might kind of help to figure out where cotangent might be undefined. And let's do the pi's over 2. What the hell? Let's just go check it out. And let's see. So now we're going to be like, all right, let's go get cosecant of pi over 2. The reciprocal of 1 is 1. Not going to show it again, but the reciprocal of 0 is frickin' undefined because you're going to put a 0 in the denominator. There is no reciprocal to 0. It's undefined. And now I'm going to leave it up to you to find out why this is true. This is equal to 0. I'm going to misspeak. Actually, no, I'll tell you. This is not mathematically correct. What I'm saying is not true, but it's kind of a cool little trick. The reciprocal of undefined in trig is 0. It's not really true. I'm misspeaking like crazy, but that little trick will work. I'll let you go through the other ones and take a peek. Quadrantial angles, learn them. Learn them, because we're about to get into it now where by the end of this section, I'm supposed to be able to ask you anything, maybe like secant of 17 pi over 6. And you're supposed to be able to give me an exact answer in 5, 4, 3,